Hey everyone, in this video we are going to solve the question of longest common subsequence on Leetcode. So what the question says is we are given two strings, text1 and text2, and we need to return their longest common subsequence. And if there isn't any, should return 0. So what is longest common subsequence? So it is the string generated from original string with some characters deleted without changing the relative order. So that means if we see the first example here, A is common in both of these string, B is not there, C is there and it is also after A, and next D is not there and E is there but it is after C. So A, C, E, both of these characters are present in this similar order in text 1. So it has a length of 3, so the output is 3. So this is the question. Let's see how we can do it. So let's say we have two strings. So first one is A, B, C, D, E and another one is A, C, E. So if we just have to check which one, what is the longest common subsequence here. So we'll start from the beginning of both of these strings. So we'll start from A. Both have common A in them. So if we keep track of a count, so both have common A in here. So let's say we can say we have a length of one common substring up to now. Next we'll compare B. So is B here in the text 2 after A? No, it is not. So up to now, up to AB, we have a length of 1 longest common subsequence. Next we have a C in the first text. So is C present in the text 2? Yes, it is. It is present after A. So we can say that up to now between A, B, C and A, C, E, we have a length of 2 of the longest common subsequence. Next we have a D. So after C in the text 2, is there a character D in it? No, there isn't. So in A, B, C, D, E and AC, sorry, it's AC. So in between these two strings up to now, the longest common subsequence is 2. Next comes E. So is E available inside text 2 after character C? Yes, it is. So we can update our count here as well. So the count will become 3. So the longest common subsequence we have found is 3. Now how we can do it in code? So we'll use dynamic programming for that. So we'll create a 2D matrix like this to solve this particular question. We'll be using dynamic programming. That means we'll be solving the sub problem first and then the whole problem. By sub problem, I mean first we need to check what is the longest common substring if we have just A and A here. Similarly, what will be the longest common substring if we have A and AB here? So let's see how we can do it. But initially, the first row and first column will always be 0. Why? Because let's say if we have empty string in one of the strings, so if either text1 or text2 is empty string and another one and the other one contains some value in it, A, B or A or anything, what will be the longest common subsequence between them? It will be 0 because there is nothing common between them. So if either any of these substring, so if any of these string is empty, the answer will be 0. So that's why the first row and first column will always be 0. Now talking about the remaining part. So let's say if we have A, so let's say if we have A in one string and A in another string, what is the longest common subsequence here? It will be 1 since both of them are equal. So we'll replace 0 with 1 here. Similarly, if we have A here and AB in another string, what will be the longest common subsequence? It will be still A. Why? Because we check previously that if the characters is not present in the another string, we'll keep using the previous value. So when we were at A, the longest common substring was 1, but when we get to B, B was not available in text 2. So we keep using the previous count. So previously it was 1, so we kept using 1 as the output. Similarly, at this particular point, when we have a and ab, b does not exist in another part of the string, in another string. So we can keep using the previous value we had, which was 1. So we'll replace the 0 with 1. Similarly, for C, if we have A and ABC, it will still remain 1. So this whole row will contain 1. Now coming to the third row, if we have AC in one string and A in another string, what will be the longest common subsequence? It will be 1, because A and A, only this one is common, and C, which is the other character, is not present in another string. And since it is not present in another string, we'll keep using the previous value. So here it will also be 1. So we can see a pattern here. What we are doing in this matrix, we are taking the maximum from the previous row or the previous column. So up until now, in the previous row, what we were doing, when we were at B, C, D, E, what we were doing, if the characters were not matching, so A and A doesn't match, A and C doesn't match, what we were doing, we kept using the previous value, the value present at the previous column. And when we get to next row here, we kept using the value present in the previous row. So what we see, if the two characters are not matching, so we can have a formula. So if we name our 2D matrix array as temp, then temp at I at j will be equals to maximum of temp at I minus 1 at j, which is the previous row, and temp at I comma j minus 1, which is previous column. So that is when two characters are not matching. So here C and A was not matching. So we kept using the maximum value, whichever one was maximum from previous row or previous column, which was 1. So here it was 0, here it was 1, the maximum was 1. So we kept using 1. Similarly, if we keep moving forward and apply this formula, so here C and B don't match. So we will use the maximum value either from the previous row or previous column. Both of them are 1, so we can use any one of them. So here it will also be 1. Next, when we come to C, then one another condition applied. They both are same now. So on one string we have A and C, and on another string we have A, B and C. So up until now, when we were up to here, the count for longest common subsequence was 1. Now we get to C. C is also present in the other string. So now the count will become 2. So that is the another scenario. When two text or when two characters are equal to each other, in that case what we'll do, we'll pick the value from the previous diagonal and add 1 to it. So if both of them are equal, then what we'll do, we'll use the value from previous diagonal, which is I minus 1 and j minus 1, and we'll add 1 to it. So in this case, yes, C and C are matching. So what we did, we picked the value from previous diagonal, which was 1, and we add 1 to it, so it will become 2. So we keep moving forward. If we have A, B, C, D here, and we have AC here, since the characters are not matching, C doesn't match with D. So we keep using the value, which one is maximum, either from the previous column or from the previous row. Which one is maximum, 2 or 1? Here 2 is maximum, so we'll keep using 2. Similarly, for the next column, it will also be 2. Now coming to the last row, if we have A, C, E here and only A here, so E and A are not matching, we'll keep using the previous value, which one is maximum, either from the previous row or previous column. The previous row is bigger, so we'll keep using 1 here. Similarly, B and E are not matching, so here it will also be 1. Now E and C are not matching, whichever one is maximum from previous row and previous column. Here it's true, it's 2 which is maximum, so here it will be 2. Next, E and D, they are not matching, so we'll pick the value either from the previous row or previous column, which one is maximum, both are equal, Here it will also be 2. Now E and E, they are equal. So what we'll do, we'll pick the value from the previous diagonal I minus 1, j minus 1. Here it was 2 and we add 1 to it. So it will become 3. And at the end, this will be the output. The element present at the last row, last column, this will be our output which will be returning. So the time complexity for this one will be O of m into n, and the space complexity will also be O of m into n since we are creating this 2D grid. So this is the drawing explanation. Let's see how we can do it in code. So first let's declare our DP array. Let's call it temp. And initially we need to put 0 for each index. So we'll use a for loop for it. So let I equals to 0, I is less than text1 dot length, and I plus plus, and at each index we need to insert a new array. So temp dot push a new array of length text2 dot length, and at each index will fill the position with value 0 for initially. Now we have created our 2D matrix. What we need to do, we need to run two for loops, one for the row and one for the column. So I equals to 1, I is less than temp dot length, I plus plus. Then for the columns, for let j equals to 1. We are starting from index 1 directly because we know for index 0, either it was row or column, for the first row and first column will always be 0. So we are directly starting from index 1. And I and j is less than temp at 0 dot length and j plus plus. Now there can be two conditions. Either the characters are equal to each other or they are not. So if the character at text1, so text1 at I minus 1, if it is equal to character at text2 j minus 1, if those two characters are same, that means we need to update our DP array, our temporary array, with the value from previous diagonal and add 1 to it. So temp at I comma j, it will be equals to temp at I minus 1 j minus 1 and adding 1 to it. Else, if these two characters are not equal to each other, we need to pick whichever one is maximum from the previous row and the previous column. So temp I at j will be equals to math.max, whichever one is maximum from previous row. So I minus 1 at j, and temp at I at j minus 1 previous column. And at the end, outside the for loop will return the element present at the last row, last column. So element present at text1 dot length and text2 dot length. So if we run this, we got one error, text1 dot length. Okay, my bad. So while creating the 2D array, I missed the equal to sign here. So that was the reason we got this error. So if we run this again, wrong answer. Oh, sorry. So it will be text2 dot length plus 1. Yep. Now it should work fine. So if we run this again, I should have used two for loops directly instead of writing this. Okay, so it's working now. Let's submit it. Cool. So that was it for this video. Thank you for watching.